for statistics, problem number 16, chapter 7. So I entered the data here, the weight of a truck. One is weight in motion into L1, and the other is the static weight into L2, and it's telling me to make a scatter plot. So I'm going to go second stat plot, and I'm going to go, well, list 1 and list 2, and I already have a scatter plot. I just need to turn this one on. So I'm going to go enter, and I want to turn it on. I have my L1 and L2. My scatter plot icon is there. So I'm going to go zoom 9, which is our stats default, and that is the scatter plot that I get. Part B says to describe the direction, form, and strength of the plot. Well, the direction is positive. I would say that the form is linear. I'm a little bit concerned about this guy right here, but not too much. And I would say that the strength is moderately strong. I'd say the strength is pretty strong. This scatter plot is comparing the weight in motion, so they weighed these trucks as they were driving on the x-axis compared to the weight that they got when they actually stood still. And so for part C, I would say that the weight in motion is pretty accurate compared to the weight when they're still. We know that the weight when they're still is very accurate, but I'd say that weighing them while they're still moving, so not making them stop, is still pretty accurate. Again, maybe a little bit of concern here when they get very heavy, but otherwise I'd say that they're pretty. It's a pretty good system. Part D asks me to find the correlation, so I'm going to quit out of the graph right there, and I'm going to clear out my screen. And to find the correlation, I go Stat, and then I flip over one to Calc, to the Calc menu, and I want to go to the linear regression. So I go 4, and it's asking me what do I want to linear regress. So I'm going to go my L1, second 1, comma, L2, and press Enter. And there are my important stats and my correlation. Well, my correlation is very strong. It's a 0.965 correlation. Then the next question it asks is if the trucks were weighed in kilograms, how would this change the correlation? Well, I mean, I know that when we do the correlation, we're doing that using ZX and ZY, and we don't really, since we're using Z-scores, it doesn't matter whether it's in pounds or kilograms. A truck's weight is going to be the same number of standard deviations away from the mean, regardless of the units in which we measure. But I thought it would be fun to kind of show you that. So if I go Stat, Edit, so I'm going to make my L3. So if the trucks were weighed in kilograms, so my L3 I'm going to make it the same as my L1. So I'm going to go L3, and it says down here it equals, and I'm going to put the L3 equals L1 times 2.2. That's 2.2 kilograms for every pound. And I'll press Enter, and that fills in my L3 with kilogram weight. Then I'm going to go over to L4, and I'm going to make that equal to 2.2 times my L2, and that fills in my L4. And now I'm going to go back to my stat plot. Well, actually, I'll just go to my correlation. I'll go Stat, Calc, 4 for linear regression, and I'm going to do list 3 and list 4 now. So second 3, comma, second 4 for list 4. I'll push Enter, and sure enough, my correlation is the exact same. It didn't change at all.